right.
Hello, everyone, and good
Morning.
morning, afternoon, evening, depending on where you are in the world.
All that, yes, that's now the obligatory thing to say as most of these things go global. My name's Andrew Brust. I have been working with SQL Server since the early 90s, Microsoft BI since the late 90s, and these days I'm also an industry analyst and journalist focused on data and analytics, also a Microsoft Data Platform MVP, so excited to bring this material to you. I'll let my partner Joey tell you about him and his illustrious background.
I'm Joey D'Antoni. I'm most of those things Andrew is. I'm just several years younger. I didn't start working with SQL Server until 1999. SQL Server 7 was my first venture into the SQL Server space. My first relational database was that other one, version 7.3, in about 96. I'm also a consultant, a tech journalist, and kind of an analyst as well. So I do wear a number of hats in my role. This is going to be kind of an interesting session because we're going to be talking about Fabric SQL database, but specifically in the context of GraphQL and Data API Builder. And I've done a bunch of talks on Data API Builder, and I think this is something that's kind of interesting because like a lot of things with Fabric, this makes it a lot easier to get started with that service. And I will hand off to Andrew to tell you a little more.
Yeah, absolutely. And by the way, Joey and I have known each other a long time, but we have never actually presented together. So this is going to be fun for us. And in the Department of Fun, we want to mention that we do want to try and keep this interactive. That's actually really easy for us because in the YouTube chat, we've got terrific moderators from Microsoft, from the team, who will be able to answer your questions on the fly while we're talking. So it's going to make us look attentive without us actually having to do much. But we will also have Q&A time at the end. And if your questions are like super interesting or real stumpers, our moderators may leave those to us. But we'll see how that goes. But let's keep this kind of fresh and fun. So this is part 4 of a 6-part series. And well, we're the first part of this second week, if you will. I mentioned this for a few reasons. First of all, there's 2 more episodes coming up, one tomorrow and one the day after. We think this is maybe the most interesting of the modules because it puts so many pieces together. We're building an application around stuff that's in SQL, that's using data in Fabric, and is also thunking all the way down to use Azure OpenAI so that we can do some really cool vector searching. That also means there's a lot of pieces fitting together, including some stuff that was built in Module 3 that gets used here. So I'm going to make sure to point that out to you in case you weren't actually attending Module 3, just so you kind of understand what goes where. And Joey, I don't know if there was anything you wanted to say about this sequence before
I think the sequencing is pretty good. The next topic will go into source control with SQL database and how this works. It's pretty seamless as far as Fabric goes. One other thing I'll just add is I've been working with the underlying technology for this pretty much since it came out, and that's Data API Builder. And this is a great implementation because it just is kind of there, and you don't have to build a lot of the componentry that you might otherwise have to build to make it work. So I think that's kind of and that's a lot of the Fabric messaging, right? Is you don't have to do as much. I think that's a lot of what you're going to learn about today, and a little bit about GraphQL and where it's good.
It's for lazy people like me, not quite so much like you. But what's interesting, actually, is that these slides will talk to some of the specificity of GraphQL that ultimately you don't have to worry about because Fabric does a bunch of it for you. But we're still going to cover it so you understand what's under the covers. In our experience, technical people prefer that. It's nice to have things done for you, but it's very uncomfortable if you don't really understand what those things are. So we're going to tell you about the nitty-gritty and then bring you up and let you know that you don't have to really deal with it most of the time. Let me advance over here. This is you, Joey.
Yeah, so coming up in next spring, we have the second annual Microsoft Fabric Community Conference in Las Vegas. I did not attend the first one, unfortunately. I was in Europe, but I attended the European Fabric Conference in the fall, and it was a wonderful experience. And this is a really good show. It's not just all about Fabric. It's going to be all about Microsoft data in general. So get yourself there. There's a discount code you can use called MSCUST to save $150, and you can register there at that URL. And I hope to see you there.
And there might be some more info in the chat about that. So hopefully MSCUST is something you'll almost commit to memory. And so we dive right into the material. But before we get into the niceties of GraphQL, what I'm going to do is show you some T-SQL, right? And this is a kind of interesting, somewhat involved T-SQL stored procedure script. And let's take a look. By the way, these demos, just, in full disclosure, these are pre-recorded demos, and we didn't pre-record them, but we've gone over them painstakingly. And so I'm going to go ahead and start this one. So this, this stored procedure is called find sessions, and it is kind of the engine of this whole application. Because what it's going to do is say we want to establish a minimum vector similarity of 0.3. We want to take an input text string. We're actually going to use another stored procedure called getEmbedding that was developed in Module 3. And we're going to reach out to Azure OpenAI in order to get the embedding for the input string. Then we're going to take that embedding and look in a catalog of presentation sessions for the top 10 sessions that are most relevant based on the session topic and the speaker name. So there's a lot of common table expressions here that are used to build that up. And ultimately, once all these CTEs are built, as you'll see in a second, we do this select of top N, and N is 10 here, at top is 10, and we're bringing back ID, title, abstract, start time, end time, URL, and a list of speakers as a JSON array. We're selecting that from one of the CTEs, and that's actually what we're going to push back to the user. We're also going to record the actual query and timing and put that in a table. So that was the script for the stored procedure. Now we're going to call it a few times. So we're going to call find sessions, and we're going to pass it a specific string, particularly just the word technology. So it's going to bring us back based on a vector search. It's going to look for the closest 10 sessions based on that word technology, and typically the title and abstract is where we're going to deal with this. So the embeddings for the sessions were already generated and stored in the table. The embedding for that input string is getting generated on the fly, and then we're using a special cosine vector similarity search to get what we want here. That's the AI magic that's involved. Now we're doing it for community and youth. And just in case like that wasn't super clear enough, we're going to do it one more time. That'll be a total of 3 sessions or 3 calls to the stored procedure. And once we're done with that, this demo will actually be done. I'll come back at the end and show you a little bit of a shim that goes over this stored procedure. And that shim is actually going to get called by GraphQL and Node.js code that Joey is going to demo for you. So here we are in ecology, which is our 3rd run. And at this point, I think our demo is done, and we can switch over to Joey, who can start telling us about GraphQL.
So if you're a SQL person, like I am, I've been writing T-SQL, PL-SQL, P-SQL, pick your flavor of SQL. I've been writing it for 20 plus years is what I always like to say when I don't like to say how old I am. You might wonder why we need another language. And GraphQL is something I first discovered when I was using Data API Builder a couple of years ago, because the Data API Builder tool, which this Fabric solution is based on, has options to use both REST API or GraphQL. The kind of interesting thing about when you use Data API Builder and you use GraphQL, it actually gives you a web interface called Banana Cake Pop. I know open source terms are weird, but that's what it's called. I first discovered GraphQL because it made a cooler demo than calling a REST API, which just returned JSON. However, I knew GraphQL was becoming rather popular with developers, and I kind of wondered why. And there are a number of reasons this is the case. One of the first is it can give you a single API endpoint for all of your data needs. So if you have a diverse set of data sources, like you're connecting to a Fabric SQL database and a Cosmos DB, maybe you're also connecting to third-party APIs, but you want to provide a united single interface to your client applications. So like an e-commerce app where the front end needs data about users, products, and orders, instead of having to hit separate endpoints for this, GraphQL can allow the client to fetch all this information with a single query. So it simplifies the API architecture and reduces client-side complexity. Or you have different data requirements and you just want to optimize the data transfer. For example, if you had a mobile app that just needed the product's name and price, but a web version of the same application that needed the description, reviews, and related items, GraphQL will allow each client to ask for exactly what it needs without overfetching or underfetching data. And I know you can do this in T-SQL queries, but how many queries have we seen from developers that were select star or maybe didn't have a where clause? Those are all kinds of things that are, I think, easier for developers to do in T-SQL. Another really good example that I like, and we've seen developers do this any number of ways, and it doesn't always work well, is aggregating data from multiple sources. One of the things about modern applications that you may or may not realize is that a lot of them use multiple data stores. I'm working on designing an application right now for a customer, and it's probably going to have a graph database, a few different relational databases based on the nature of their data. It's also going to have Elasticsearch, and there's also the potential for it to be making API calls. So you have all of these different things, but you want to present it as one cohesive data set. Traditionally, this was like the area where BI tools like Power BI would shine, but that doesn't always work for an online kind of application because you need a single place to join those results. And how do you even join those results? And with GraphQL, if you had maybe, say, a travel site where you had hotel details coming from a SQL database, flight schedules coming from the FAA API, and user reviews from a MongoDB database, GraphQL can bring all this together into a single cohesive data set in a JSON format. So let's talk a little bit more about some of the other options we have in GraphQL. In Fabric, the Fabric API for GraphQL is a data access layer that's going to enable quick and efficient querying of multiple data sources very easily. This is just building on top of the Data API Builder solution that Microsoft had debuted at, I think it was SQL Bits a year or two ago is when it got announced publicly. But GraphQL lets you use the simple GraphQL query language and the result sets, which minimizes the time it's going to take for you to develop an application. The nice thing is this is all pretty straightforward and easy to deal with. Currently, it supports a number of data sources, not everything, but Fabric Data Warehouse, Lakehouse, mirror databases, Fabric SQL database, other Azure SQL databases, and as well as data marts. And it has a number of features that makes your life a little bit easier. And I think the biggest one is automated data source schema discovery. One of the challenges I had with my Data API Builder app is I always forget my app is based on Azure VM sizes, and I always forget what the exact names of the fields are. And that kills me because it's kind of difficult for me to remember that off the top of my head. So I always end up going back to the database and doing that. In the Fabric API, it's going to pull in some of that data for you to make it easier. It can generate things like queries and mutations. We'll talk more about mutations later, but that's a fancy way of saying DML in GraphQL. That's data manipulation language if you're new at this. It supports views, stored procedures as data sources. So you kind of define a data source in the API as a view or a stored procedure. If as an old DBA, my preference is for you to use stored procedures because you can pass in parameters and they compile better and all those other reasons why you like to use them. But you can also select individual objects like tables. You can expose into specific columns, and you can monitor the API behavior with a dashboard and request logging. So we have lots of different ways we can do things, but effectively this is just in kind of an easy API layer that sits on top of our SQL database and Fabric that we can use. So some of the use cases for GraphQL, we've talked a little bit about this. And just to go a little bit deeper, developers can interact with your API, build queries, and test results without writing extra code. So the goal is to speed up development and troubleshooting and improve developer experience. It feels like my entire career, we've been doing a lot of things for developer experience, and developer experience is still kind of what it is. But these trends kind of go over time, and this is definitely something that's been trendy and more popular in the last few years. I've seen a lot more use cases for GraphQL APIs as opposed to just using REST calls, because it can be a little bit more specific, which is a little bit better. Like if you're using a microservices architecture and you want to simplify the front end's interaction with multiple services, like if you have a banking app that has separate services, data services for accounts, transactions, and investments, that GraphQL API is going to act like the gateway, allowing your client to query all those services through one API. This reduces network calls potentially. It can possibly improve performance, and it gives you better code hygiene because all that code's in one place. Another example might be if you're doing personalization in a website. Like if you had a video streaming app like YouTube, where you're watching right now, and you wanted to see a personalized dashboard with movies, trending content, and watch history, GraphQL can bring all that together in a single call. This is helping enable, customized experiences. And once again, fetching all that data at once helps reduce the latency and bringing it together. It also means you might have to have more hardware for your GraphQL server, but we're not talking about hardware because software as a service models, but keep that in mind because you do need memory to bring all those results together. You can also optimize for diverse front-end clients. So if you have mobile apps, web apps, IoT devices that all have different data needs from your service. Like I use a fitness watch, I use a cyclocomputer, and they show things like power output and calories burned, and I can see more detail on the mobile app than I can on the smartwatch itself. GraphQL lets each client request only the data it needs, so this can improve user experience by returning less results on the dumber device side, where there's less processing power there to deal with it. It's a versatile language, and it does help solve many modern application challenges. And what it does is provides a flexible, efficient API that can be a powerful tool in scenarios like data aggregation, real-time updates, and personalized experiences. And what Andrew's going to talk about next is some GraphQL data paths, the schema types, and queries and mutations, etc.
Indeed. All right. So this is one of those fun build slides. So again, remember I said we're going to tell you about some details of GraphQL that ultimately you don't have to worry about, but it's still best if we tell you what's going on underneath the covers. So if you were going to kind of implement a GraphQL API from scratch in whatever language you were working in, you would want to go out and actually find an open source GraphQL server that worked with your language. And
like Data API Builder from Microsoft,
for example. So there are several of these. And again, ultimately, you won't have to worry about this, but a GraphQL server is there. It's the thing that ultimately is generating the API based on some specifications from you. It's the one that's putting the API out there. And sort of I guess the direction we were given, and I'll share it, although it's an oversimplification and not perfectly accurate, but think of the API as almost being like a combination of views for selecting data and stored procedures for manipulating data, for updating, deleting.
I think that's a really good
inserting data.
That's a really good comparison.
Yeah. It's a good rule of thumb just to get your arms around it at the beginning, but it gets a little confusing because ultimately you don't need views and stored procs,
right?
But you can have them. You can also just have raw tables, although, yeah, the former DBA over there is not going to be real happy with direct table access, I'm guessing. You're not really grumpy enough to be a DBA anymore.
It's been a while since I've been a DBA full time.
Anyway, GraphQL generally is going to be a good abstraction over all kinds of data sources, including relational databases, including NoSQL databases, and for that matter, including just data files, whether they be super flat things like CSVs or fancier things like, let's say, Parquet or Delta sitting in cloud storage somewhere. It doesn't really matter where the data is coming from because, I mean, to the ultimate developer, because the API is abstracting all of that, right? And in effect, it's querying these things on behalf of that application developer. And there is that application developer. And that application developer is going to be thinking of the world in terms of JSON. Everything is JSON. We're going to put together a JSON document either to request data or to manipulate data. And as Joey already alluded to, when you're requesting data in GraphQL, that's called a query, which is fairly straightforward. When you're manipulating data, that gets called a mutation, which is a funny word, but if you think of immutable systems and mutable systems, then mutation kind of makes sense. That JSON document's going to go to the GraphQL server and API, which is going to unpack it, query on your behalf, and then it's going to send back a single JSON document that's going to be a combination of the result set as well as any messages and any errors. And as the application developer, it's going to be up to you to unpack that and then push it out to whatever your interface is. If that's a GUI, then you'll put it in your GUI. If you're going to be running kind of bare bones and doing stuff on the console, like we are in our example, then you're gonna output things to the console, as you will see in our final demo here. But that's the general flow of things. Now, let's talk about some of these basic concepts. These slides are a little bit funny because we kind of say what we're going to say, and then we say it, and then we say it some more. But the schema, of course, is an important thing, right? And really, this is more about vocabulary. I'm guessing most people in this audience know what a schema is. But in the world of GraphQL, a schema consists of types and fields. A type can be thought of as akin to a table, and a field can be thought of as akin to, well, a field or a column. What's nice about the API, and Joey kind of mentioned this, but I'll reiterate it, is even though the API is an abstraction layer, and even though it defines the types and the schemas, you can still be selective as to what part of that schema you're bringing back. You don't have to bring back every field in a type. So the types are defined for you, which is great, but you still get to specify things like which fields you're interested in seeing. And as we will talk about, you also get to specify conditionals. We'll get there in a moment. A little bit more vocabulary before I pass back to Joey. Types are going to be those table-like things, but really GraphQL, is it okay, Joey, if I say it's really an object relational manager to some extent?
It is kind of like an ORM. Typically, like Andrew said, and I said earlier, you can present tables there. In my apps, when I build these with Data API Builder, I've always exposed storage procedures or views just as both kind of a security abstraction and just to mask complexity. That way the developer is not having to join any data behind the scenes. They're just hitting a single source in the database and bringing the data they need back.
But regardless of whether we're hitting the tables directly or just using views and stored procs, we're still presenting some tabular data. The thing is,
as an object, yeah.
Right, exactly. Yeah. So because it's an ORM, in effect, we don't call those things tabular data, we call them types, right? So we're in an object-oriented world. And again, queries are what you use to request data. Mutations are what you use to create or modify data. And you can have filtering conditionals on either of those. There's also something called subscriptions, which we don't cover in this module, but we mention it here for completeness. And subscriptions kind of let the GraphQL API almost implement like a change feed. Not a super fancy one, but if you can think of change data capture or a change feed in lots of databases, that's what this is about. So it will actually push out notifications to the application when data is updated. And I think we now go back to Joey.
Yeah, so let's talk a little bit more about GraphQL and how it works. You've heard a lot about it, but This is a query language that's specifically designed for APIs. Unlike traditional REST APIs, where often you're going to receive way too much data or too little data. A lot of times, if you ever look at the queries that get spit out by a standard REST API, it can be pretty ugly, and it doesn't allow the developer a lot of granularity in what they can request. A lot of time it's like select star from database object. GraphQL provides a powerful and efficient way to retrieve data, which is really helpful for those web or mobile applications that rely on speed and precision. And this flexibility is why developers have really started to go towards using GraphQL in more cases. If we think about SQL traditionally, which is the long standard for managing and manipulating relational databases, and will be the standard for manipulating relational databases until long after I am off this planet. It's widely appreciated for its simplicity and ease of use, which makes it a staple for using database operations, whether it be among software developers or even business analysts. SQL is, the language, but its primary focus is really focused on querying that data from a structured relational model, which really introduces challenges in kind of modern applications for development purposes when you're dealing with either large data sets or trying to integrate multiple data sets efficiently. One of the things that you get is some level of flexibility, and not to sound like a MongoDB advocate or anything, but you do get precise data fetching versus across structured and unstructured sources versus having rigid schemas. You're going to get potentially some performance benefits using GraphQL, and that's not necessarily a performance benefit over using a really well-structured SQL query. It's a performance benefit over using some terrible query that your API spit out and selected way too many records. You do have a much better versatility of data sources. So GraphQL combines SQL, NoSQL, and external APIs, and that's something that's really powerful. And of course, it's focused for modern applications with dynamic front end. So the key differences here, GraphQL has flexibility, so it allows you to bring in only the data you need, no more, no less. Whereas SQL, especially through the context of a REST API, may not allow you to do that. And you can unify that data from multiple sources into a single source. So they serve different purposes, but are both critical in the same ecosystem. SQL is foundational for data management and analysis, and it works really well for structured and relational data, like in your gold layer. GraphQL, though, can take API interactions to the next level and just really improve the way APIs hit databases, which is how many modern applications are developed. So they both have their place, and especially when you use something like stored procedures, you can get the best of both worlds. But let's talk a little bit more about how we query data with GraphQL. So in this section, we're going to talk about how queries in GraphQL work and what they look like, including the syntax for selecting fields and filtering data. So let's kind of dive into that here. So in SQL, if you're new, just in case you're new at this, the select statement is used to retrieve data from the table. So let's kind of take a look at both of these queries and kind of compare and contrast them. With select star from country, that's going to assume a table called country. And by the way, slight slide error here that I didn't fix. The country is singular in the SQL query and plural in the GraphQL query. I'm just noticing that. So select star from country.
Can I cut in there? That actually points out that the names of your types don't have to correspond necessarily to the names of your physical tables. So that's part of the abstraction layer.
That is a good point. And GraphQL is case sensitive, by the way, as I've learned many times when I've tried to do my banana cake pop demo and been like, why is my object VM size is not available? But that's a very good point, Andrew. But if you do a select star from country, what's going to happen in the database is it's going to scan, assuming country is a table, it's going to scan the entire table, return all the records in that table because we said star. So that means all the columns. There's no where clause to filter, and it's going to bring them back in no particular order. Here in our GraphQL query, we're specifying country. So we're specifying the same object, and we're telling it to return specific columns: country code, name, capital, AWS region. I don't know how that made that into a Microsoft slide deck, but I didn't write these slides, so I'm not going to take credit for that. Currency, emoji U, which I don't even know what the difference is. One of those is the flag, presumably, native, and phone. And that's going to just return what we're asking. So it can mirror the entire data structure, or you can bring back specific columns. You can also filter that, which we'll talk more about in a few slides. But the strengths of each are that, SQL is really ideal for those structured relational models and direct database interactions. It's easier for bulk data processing within the context of a database, whereas GraphQL is superior for API-driven applications where data requirements can be dynamic, and it can reduce overfetching by tailoring those API queries to specific client needs. I say this is really going to be useful for those modern applications which have a client-driven approach to data retrieval. Client in the meaning that it's a client application and uses client code and doesn't inherently make SQL very well-crafted SQL calls. Both of these are powerful, but their use cases are going to depend on the context of the data here.
So yeah, I don't know what the subliminal message is that SQL's in red, but that's not necessarily something we condone.
Or anything about AWS region. That one's a little bit of a head.
Well, that's just to show Microsoft's very very neutral. Anyhow.
Yeah, so I'll hand back to Andrew to talk about querying and filtering conditions.
All right, very good. So I've alluded to this a couple of times, but the point is that queries aren't just for requesting data in some static fashion. We are just like in a SQL query, you can have a where clause. In a GraphQL query, we can have filters, and we can also have arguments, which have filtering capabilities. And actually, the difference between the two gets a little tricky. I'm not in love with that part of this GraphQL scene, but there it is. So again, what we're going to talk about now is filtering data. I'm going to kick it off, and then I'm going to punt it right back to Joey. But so you already saw the straight select star versus the GraphQL equivalent. Here, we're doing something a little bit more sophisticated, right? We are not doing a select star. We're getting specific columns, and we have a condition. So let's actually start with the GraphQL, which is a little bit, I don't know, a little bit rougher to fully comprehend, given the kind of esoteric syntax that exists here. But if you take a look at it, it's a query. So we start with the word query. We are hitting the languages type, which once again is not a one-to-one correspondence with the table name. And we're specifying a filter, and we're using this lovely syntax where we're saying the code field must be equal to, that's what the EQ is, to the string EN.
Was Jeffrey Snover involved in developing GraphQL?
I do not know who had such a love of obscure syntax and braces was involved here, but at least one such person was. But ultimately, if that thing perplexes you, now you can cheat and use the SQL on the upper left part of the slide and just understand that that is equivalent to saying where code equals EN. And then we're asking for the code column back, as well as the name column, the native column, and RTL, which presumably is true if it's a right to left language like Arabic or Hebrew. And that's really it. But let's be clear here. There's a filter, if I can wiggle the mouse here. This is a filter expression, but it's also embedding an argument where we're saying code as a column has a conditional on it, right?
Yeah, these statements are the functional equal of each other.
Yeah. So what's weird is you can actually, without the keyword filter, you can still specify conditions for a specific field, but the filter condition is more flexible. And in fact, if you look at the slide the text on the lower right of this slide, you'll see that we can also string together multiple conditions with ands and ors and get a lot more sophisticated. So that's kind of the 101 of filtering and conditions. And then I pass it back to Joey for the 102 and 103.
Yeah, we're going to talk about fields and argument here. And I'm going to use a couple of SQL examples, and I'll just talk through them a little bit because I don't have them on the screen here. But in GraphQL, fields and arguments are the backbones of how queries work. Fields are almost 100% analogous to columns in a SQL query, especially going against a database object. they define exactly what data you want to retrieve. For example, if you're querying for products, you might specify fields like ID, name, and price. In SQL, you're often going to use a where clause to filter data, or an order by to sort that data. In GraphQL, the arguments are going to perform a similar role, but they're applied directly to specific fields or operators. So like in SQL, you might write select ID, name, and price from products, where category equals electronics, order by price descending, right? So what that query is going to do is give us the ID, name, and price of all our products, where the category is electronics, and then it's going to give it to us in price descending from top to bottom. To do the same thing in GraphQL, we're going to create a query string, but in our products column, we're going to associate both of those filters, which are our arguments, with the products column. So we're going to say products, open paren, category colon, electronics, comma, sort, price descending. And that's how we're going to do it. And we're going to ask the rest of the query to return ID, name, and price. The nice thing about this is it can make GraphQL a little bit more intuitive for modern apps that require filtering and sorting on the fly. Like I mentioned, it's nothing you can't do in a stored procedure in the database that you might return from an API call, but it is a little bit easier for a developer who maybe doesn't have that advanced SQL experience. If you're familiar with SQL, you might want to think of GraphQL as a query language that combines the power of select statements with a focus on flexibility and precision. Those fields, which are going to be the same, pretty much the same as columns, and arguments are akin to where clauses, allowing you to fine-tune your data retrieval without having the rigidity of a fixed table or schema relationship. Ultimately, the goal here with GraphQL is to enable dynamic, efficient queries that return only the data you need without overfetching data or underfetching data.
The way you're sort of saying all this, Joey, it's as if somebody kind of wrote this narrative for you, but I just want to point out that this is all original from Joey. So he's really got a lot of value to add here. I'm learning too.
Yeah, thanks, Andrew. I appreciate that. Filtering in GraphQL is going to rely heavily on arguments, which are going to be these parameters that you're going to include in your query to specify exactly what data you want to retrieve. These are the building blocks that we talked about. So that example I gave you, where we're specifying products as a column and we're saying category electronics. Electronics there is going to be an argument that's applied to the products field. It's going to filter the data at the API level, ensuring that only relevant results are returned. Now, what makes arguments powerful? If we take that a step further, GraphQL allows you to combine multiple arguments seamlessly to refine your filters. For instance, if you wanted to filter by price range, you could say products, category electronics, comma, min price 50 and max price 500. And that would return to you all the products between $50 and $500. You'll note that that filtering is taking place client side, so that may be more expensive. And you need to make sure you understand that, because you have to size your API server appropriately. But it is part of that argument. And in Fabric, that's going to be a little bit of different things. We're not sizing specific components individually. But what this query does is allow you to have min price, max price, and category all as arguments. And these are going to work together to give you that precise filtering to ensure you're only retrieving products in the electronics category that are priced between $50 and $500. While this may sound simplistic to somebody who's worked on a relational database, when you're working either against a NoSQL store or maybe a set of files like Parquet files, that becomes a little bit trickier to deal with in terms of how you manage that. And so that's something that is different with GraphQL, and it's going to achieve the same result with more flexibility and clarity. And the key advantages here for those client-driven queries in the dynamic filtering. So you can simplify your filters, which makes it ideal for e-commerce, social media, or analytics, where data requirements may change frequently. And instead of having to do multiple changes to handle a different result set coming back from a database, you can just make one source code at your API level change and potentially take that back. The other thing Andrew mentioned a little bit earlier that I think is kind of interesting is that you can combine filters dynamically to write complex queries with logical operators like and or. So not just having an and or. This is like the hardest thing to say and make sense. But you can combine and or. So let's talk about how these logical operators are implemented as part of filtered commands. back to our products example. So if we had products that are in the electronics categories and are priced between $50 and $500 or are on sale. So this is something that's kind of you can do this in SQL, but it's a little bit challenging. And if it has to be done dynamically, like, you can change it in the client application as opposed to changing it in the database, especially if this is maybe something for a short-term thing, like a holiday sale. And instead of hard coding those filters or creating separate endpoints for these complex queries, this can allow GraphQL here can allow clients to specify logical combinations on the fly, and you can define your exact needs, mixing those conditions pretty seamlessly. And it's easily extendable. So you can add additional conditions without changing the structure of the API. You can add filters for product availability, ratings, or other attributes without having to modify the backend database. And this is where this becomes really powerful and lets you build precise, complex queries with ease. And it helps you combine conditions and retrieve just the data you need while keeping the API later and potentially the backend database better. And in reality, like in a production scenario, what this might be is you might make a change on that API and you might handle some of that upstream on the client layer, but it might be something that might be the short-term fix. And over time, you might adjust your database to match those requirements. Or if it's a temporary thing, you might just leave it at the API layer. But that's just some of the different ways folks are doing things with GraphQL. And I'll hand back off to Andrew.
And Joey, you alluded to this, and it's occurring to me that that's why a lot of your narrative is so polished here, is that there is a common technology called the data API builder that Microsoft, that Fabric is leveraging for what we're talking about today, but is also leveraged by the various flavors of SQL Server and Cosmos DB. So learning here is going to be portable to other platforms. Go ahead. Sorry.
And Postgres and MySQL.
Okay. Thank you.
Yeah.
So there's a lot of I don't know. This can be applied in multiple ways. So if it seems like a bigger investment than maybe something like Fabric would normally call for, there's also a payoff for that. So we're going to talk about inserting and updating now. I'm actually going to try and be brief so that we can keep to our time constraint here. But just as we can have queries to bring back data, here is an example of a mutation, which in this case is calling an underlying function to effectively do an insert into the country's type. So we're adding a country, and there is no filter condition here. Of course, for an insert, you wouldn't really have a filter condition, but we're taking the easy way out because mutations can also update existing rows or delete existing rows. And for there, you absolutely would need a filter. So though you don't see a filter in this particular example, just realize filters apply not only to queries, but also to mutations that do updates and deletes. But otherwise, you see what's going on here, right? We've got all the values that we're setting for all of the fields in this type. We're basically adding data for Japan. We have the emoji, and I suppose the U is Unicode, but I'm not 100% sure of that. The native expression of the language in its native character set, and then things like a country code and a continent code, and so forth. So that is that's the basis of it, right? If you can do queries and you can do mutations, if you can master this little kind of JSON, or that corner of the JSON world, that's actually all you have to do in Fabric to build out an API. The code that surrounds that is essentially generated for you. Joey, did you have something to add there?
No, you're good.
Okay. So again, we say what we're going to say, then we say it. We kind of say what we said. But the mutations, it's very easy to get into GraphQL and just do query. But mutations are obviously important too. If you think about the letter CRUD, create, retrieve, update, and delete, 3 of them are covered by mutations, and only 1 of them, the R, is covered by queries. We need both. And remember that when this is all getting put together, you are going to be specifying a type and ultimately building out a big payload that's going to make up the body of your JSON document. And although the slide says you have to create or write or create these, in fact, most of it is built for you, but the demo will make this super clear. And then I think, Joey, we shuttle back to you.
Yeah, and after executing a mutation, the server is going to return the requested data, which allows the client to immediately update the user interface. However, it's one of the things that can happen with mutations, less likely than retrieval, is you can get things like primary key errors. So we have to deal with those things. So how do we deal with them? And handling these errors is effective for creating robust and user-friendly GraphQL apps. There's an error handling mechanism that will give you the message, the location, the extensions. The other best practice is to always make sure that your server is returning the error information in the standardized format so that your users can see, have clear and understandable message. Vague errors like something went wrong should be avoided. I feel weird talking about this in a Fabric session, but hint, hint. And then also, if you want to provide partial data and say why some of the records failed, like, for example, the classic SQL Server error of data being truncated, string or binary data being truncated. Microsoft finally fixed that in 2019. If you can do that to help users understand where their failure took place, do that in your apps. And let's hand off back to Andrew to do the JavaScript demo.
Great. Well, and actually, I'm not demoing. I'm just talking about it here. I'll be demoing one more stored procedure, which is a bit of a goofy one. But this is actually all the JavaScript. And when I say JavaScript here, we're really talking about Node.js backend server code. This is all the JavaScript code necessary to issue a query to the countries type and bring back code, name, and capital. So you'll notice that we're going to reference an endpoint that's at the very top of what's going on here. And Joey's going to show you how to get the endpoint for your GraphQL API inside of Fabric. Everything's JSON, so the content type is always going to be application JSON. You're going to send some kind of an authorization token. Joey's demo will it'll have a bit of a
in the Fabric case, that's always going to be an Azure one.
Yeah, it's going to be Azure, and in our example, we're going to do a challenge dialog to get the credential, which is a little goofy, but it'll work in demo land. And then we take the query here, right, and we JSON stringify it up, and that becomes the body of what we're sending over as to the API. So we're setting these headers, this body, and then we're going to get something back. Now again, this code, ultimately, you're not going to have to write. It's going to get generated. And even the code that gets generated is simpler than this code with these arrow functions. But basically, you're going to get a response object back. And if you parse that as JSON, that's going to give you your result set. You'll also be able to strip out errors, both errors on the data and general errors that you can catch down below. And that's the gist of it. You're going to send a simple document. You're going to get back a simple document. You're going to parse that simple document. And then you're going to take care of presenting it to your users, again, either in a UI or just at the console, as we're going to show you. So I have one more little T-SQL demo here, and I feel a little guilty about it because I already showed you find sessions, but because this is a slide I put together. Things are a little Rube Goldberg here. The find sessions stored proc that you already saw is calling another stored proc called get embedding that was developed in module 3. That in turn uses an extended stored procedure called SP invoke external REST endpoint. Say that 20 times fast, have fun. But this is a super important thing. This is what lets us actually get out and make API calls, right? And this is what's being used to go to our Azure OpenAI deployment that uses the text embedding ADA 002 model to generate the embedding. The problem with that whole chain of events is that it makes the result set from find sessions somewhat indeterminate and ultimately not directly callable by GraphQL. The workaround is to actually put a very thin wrapper around find sessions. That's going to be called find sessions wrapper. That's going to use with result sets to make it callable by GraphQL. I'm just going to show you that wrapper function, and then Joey in his demo is actually going to use it. So here we are, and I haven't started this recording yet, but notice this thing is called find sessions wrapper, and all it's doing is taking an input string, and then it's calling find sessions and passing through that same input string. So this is a very simple wrapper, but it does a with result sets at the bottom so that we can be very explicit about the shape of the data coming back. You'll also notice that the very last column on line 23 there is called distance, which is slightly different from what gets returned by find sessions, where it's actually called cosine similarity. You're going to see that right now. We're going to call both the underlying find sessions stored proc and the wrapper as well with the same input parameter. Notice the last column here is called cosine similarity. When we call find sessions wrapper with that same input, we're going to get the same visible results back, but that last column is actually just going to be called distance. If you're really observant with your eye, you'll see it, right? Okay. Yeah. And then just to make it super clear, we're going to call, we're going to run the whole script, call both stored procs, which is going to return two result sets. We're looking at result set 1 right now, and now we're going to switch over to result set 2. I'm kind of happy that the UI in Fabric can handle multiple result sets, and notice the last column is called distance. The type is actually also different, but you can't tell that here, right? It looks pretty much the same, but that's our cue that we use the wrapper instead. And now actually we go back to Joey, who's going to have a much nicer demo that strings all this stuff together.
Well, sort of. There's some like JavaScript windows, but here we are back in Fabric, and we're going to create a new item here in the same workspace as our database. And our new item type is going to be a API for GraphQL, sorry. And we're going to click on this, and it's going to create here. We're going to give it a name. In this case, GraphQL. I think it's API, yeah. Finder, find sessions. I didn't have this memorized like Andrew did. So that's going to create, and what's really cool about this is this is so much easier than working with Data API Builder. I love Data API Builder, but it's very much a developer-centric tool. So we're going to say use single sign-on here. It's going to use Azure to sign on, not Azure. I wanted to say Azure Active Directory, and I almost did. And then we're just going to connect it to the find sessions database, and I'm going to fast forward a little bit, and we're going to choose the stored procedure. And it's the wrapper that Andrew just showed. And then
which you can't tell because it's cut off at the right, but it is the wrapper I just showed.
Yeah. Here you can see it automatically populates with some of the items that are available. If we do Control plus Command plus, so we're going to specify a query. And Copilot's going to help us here a little bit by populating some of those fields, because it knows what fields are available in that find sessions wrapper. And since we're a little short on time, I'll skip some of this population so you can see that. And then we're going to put a text filter here on. And we're looking for Oliver in the text. And we can see here in our results set that we have all the speaker results that came from Oliver Smith. We can also change that to Europe, and we can see things that have Europe somewhere in the abstract. So now that we've got this GraphQL, I'm going to fast forward a little bit. We can have it generate the code for us, which is really cool. And we're going to have it generate this code in Node.js. It's going to import the token, and we're going to see how that works. Here, we're going to use the interactive credential, which is just a browser thing, but you can do this in a more production fashion. And so we're going to go from here into Visual Studio Code using JavaScript, and we're going to go ahead and paste that code And we're saying acquire a token. Don't do this in production, of course. You don't want to have interactive sessions. And the way you do this in production would be to give the application its own app registration. We're going to look at our text string, Europe. We see our async response, and we see the function we're actually fetching the data. And here we're going to go ahead and initialize npm and try to run it. We can see our package.json. That's the crux of our node code. And then we're going to go ahead and run this. We can see we have our package.json, our find sessions.mjs is our core code. And we'll go ahead and run this using npm.
First, we're adding the lovely package
library
for the Azure identity stuff.
Yeah, and let's go ahead and get a little bit further along the line. So our package compiled, we've added that. And here we can see that the testing code here, we actually don't have a test, but this is where you would place your unit test if you're a JavaScript developer. And we can see the app, and let's go ahead and run the app.
And this first run's going to be a little ugly.
Yeah, there's an error here. It just returns some stuff. So let's go ahead and cut to the fix here.
The stuff's okay. We just don't have a lot of white space in between. So
yeah,
we're adding that here. And then we're going to get rid of the hard-coded input text and actually grab that interactively from the user. That's going to require adding one more package, though.
Yeah, so we'll kind of flick through that. And then here we go. We'll do a clear screen and do a rerun. There's the package we added.
And this is going to be the pièce de résistance.
Yeah, here we go. This is the finale.
So now we're prompting the user for the input. The user's typing it in. That gets passed to the stored procedure, which calls the other stored procedure, yada, yada, yada. And we
have white space. Yay. That's that's the crux of that demo. And we're a little short on time, so I'm just going to cut to the end here. Do we have any questions left? We're pretty short on time, but you can post a question at the link scrolling across the bottom here. Of your screen. And if you'd like to review some additional resources, we have gathered many for you at the link on the slide. And I think Andrew and I are both on LinkedIn. I'm on Blue Sky. So if you have any other questions for us, feel free to ask.
I'm on Blue Sky too.
Cool. I will find you.
AndrewBruss.info on Blue Sky.
Cool. I'm joeyDantoni.com.
Cool. All right.
All right. Thank you, everyone, and have a good rest of your afternoon.